Okay, so as I hope you guys all know, you have a test coming up on Friday. So this week, I'm going to just try to work through the worksheet pretty fast, and then we can switch over to the exam review. If anyone has any particular questions on that, you can ask them right now. Otherwise, I'm just going to do what I just said and work through the worksheet as fast as possible and then switch over to the exam. Anything? Cool. So find the derivative of each function. So what rule am I going to use here?
Product.
Yes, exactly. So product rule is first times derivative of second time or plus second times derivative of first. So the first right here is 2x minus 3, and then its derivative is going to, so it's 2x minus 3. Its derivative is going to be just 2. Derivative of the second one is going to be, so this guy is x to the 1/2. So that's going to be equal to 1/2 x to the negative 1/2 plus 1. And then the second is just going to be root x plus 2. So I think this is basically how you're expected to put it. You probably want to just put 2 in front just out of convention, but you aren't expected to distribute anything. Does that make sense to everybody?
Yeah.
Cool. What about this guy? What rule am I going to use here?
Product and quotient.
Yeah, exactly. So let's first find what the derivative of the top is by using the product rule. So again, that's first times derivative of the second plus second times derivative of the first. So that's 4x. And so now we have, this is the derivative of the top and then the bottom. So what is the product rule?
First times derivative of the second times derivative of the first.
Yeah, sorry, did it? Sorry, go.
Sorry, I meant to say plus in between the first times derivative of the second plus the second times the derivative of the first.
It's okay. I think I also misspoke because I meant to ask what's the quotient rule.
Oh, sorry.
No, you're good. Does anyone know the quotient rule?
It's u prime v minus v prime u over v squared.
Prime v minus v prime u over v squared. And that is the derivative of u divided by v, right? So sometimes this is said high d low minus, low d high minus high d low, all over low squared. Cool. So then this guy right here is going to be the derivative of the top. And then when we do this, it's just going to be 2. So we do the derivative of the bottom also. So the derivative of the bottom is just 6. So that's v prime in this case. This is u prime in this case. So u prime is that monstrosity right there. And that's going to be times the bottom. So that's 6x minus 7 times 2x squared plus 3 times 5 plus 4x times 5x plus 2. And then that's all over just sorry, I still haven't actually written the second half of this because I ran out of space. So I'm going to erase this and start writing over. But so we do 6x minus 7 times the derivative of the top, so that's that 5 times 2x. And then we subtract the derivative of the bottom, so that's 6 times the top, so that's 2x. All that's over 6x minus 7 all squared. So that guy is, I mean, so this is basically just making sure that you know how to stack rules. I doubt that they will give you anything this messy on the test, but you should know how to combine them, mix and match. Does this make sense to everybody?
Yeah, I just have one quick question. Why is there 6x minus 7 on the numerator?
So the 6x minus 7 is going to be attached to one of the two units.
Okay.
So it's because if you look at this guy, one of them just has a regular old v, right? So in our case, v is equal to 6x minus 7.
Okay.
And then the other one has the derivative attached.
Okay, thanks.
That makes sense?
Yeah.
Cool. So find the equation of the line tangent to the graph f of x divided by x minus 1 at x equals 2. So what do we need for the equation of the tangent line? Two things. Remembers it from last week?
For the tangent, you need to find the derivative of fx.
Yeah, exactly. So, and then what's the second thing we need?
The y for x.
Yeah, so then we just need a point x, f of x. So in that case, it's going to be 2 over 2 divided by 2 minus 1 is equal to 2, 2. That's my point. So this guy, the derivative of, I can use the quotient rule. Another thing, if you want, you can actually get away without ever using the quotient rule by just changing it to a product rule question. So if you want, you can change this to f of x is equal to x times x minus 1 to the negative 1, and then just treat this as a product rule. But I think it wants us to do the quotient rule. So in general, the quotient rule is slightly quicker. It just means that you don't have to memorize the second rule. So we're going to do low times the derivative of the top, which is derivative of x is just 1, right? Derivative of the bottom is also just 1. So and then we have minus the top times the derivative of the bottom all over the bottom squared. So that's just equal to negative 1 over x minus 1 squared, right? Does that make sense to everybody?
Yeah.
So now what happens if I plug in 2 for this? Over 2 minus 1 squared is equal to negative 1. So I have y minus 2 is equal to negative 1 times x minus 2. So we get y is equal to negative x plus 2 plus 2. So y is equal to negative x plus 4. Cool. Does that make sense to everybody?
Yeah.
Cool. So assume the total number in millions of bacteria present in a culture at a certain time t in hours is given by the function n of t is equal to 3t times t minus 10 squared plus 40. So how am I going to do this guy? How am I going to find the derivative of n of t?
Do you use the chain rule?
You could use the, yeah, I guess technically you do use the chain rule. It's not a very interesting chain rule.
Or like the product rule, maybe?
Yeah, so the product rule is the more interesting thing that's happening here. Technically, you do use the chain rule because you're doing the derivative of the inside also, and the derivative of the outside. You have to do the derivative of this thing. And in order to do that, you do the derivative of the inside and then the derivative with regard to the outside. But the derivative of the inside here is just 1, right?
Yeah.
So there is a chain rule, it's just not a very interesting chain rule. So what is the derivative of this guy right here? It's just going to be 1 times 2, because then I'm just doing a power rule here, t minus 10. So it just becomes 2 times t minus 10. And then I'm doing a product rule. So what does this come out to as a product rule? So I do first times derivative of the second, which we just determined is 2 times t minus 10 plus second, so that's t minus 10 squared times derivative of the first, which is just 3. So if I simplify this guy, that becomes 6t squared minus 30, sorry, minus 60t plus this becomes 3t squared minus 60t plus 300, right? And then the 40 goes away, right?
Yeah.
But actually your answer key has you leave it in this form. But if you wanted to distribute this, and then so you combine things, you get 9t squared minus 120t plus 300. But this is perfectly acceptable. So then find the rate at which the population of bacteria is changing after 8 hours and after 11 hours. So this is just asking me basically to plug in 8 into this guy and then to plug in 11 to him. And then you get for n prime of 8, you're just going to get negative 84. And for n prime of 11, you're just going to get 69. So that means that there's at 8 hours, your population is decreasing at a rate of 84 million, and at 11 hours, your population is currently increasing at a rate of 11 million, or sorry, at 69 million. Does that make sense?
Yeah, I just had a quick question for A. How did you get 1 times 2 times t minus 10?
So if you treat this as a chain rule, then the derivative of the inside is 1. And then you have to do the derivative of the whole thing, like of the kind of outside. And at that point, it's just a product rule. So just, sorry, not product rule, power rule.
Okay, yeah, I see that.
That makes sense?
Yeah.
Cool. Any other questions? Cool. So here is another one where we're just going to have to apply multiple rules to get what we want here. So this guy is a more interesting chain rule because the inside actually matters, or the inside is going to be something other than 1. So if I look at what's the derivative of the inside here, it's going to be 6x squared plus 9. And then that's going to be times, now I'm treating the whole thing as a unit, and then I'm doing the power rule. So it becomes 5 times 2x cubed plus 9x all to the 4. Does that make sense to people?
Yeah.
Cool. So similar idea here. I'm just going to change this to x to the 4 minus 12 to the 1/2. And then this guy goes to, so the derivative of the inside is just 4x cubed. And then the derivative of the outside is, we do 1/2, and then we get x to the 4 minus 12 all to the negative 1/2. And then I can plug in 2, but that would just be, and then when I plug in 2, to get the slope of the tangent line, I would get 4 times 8 times 1/2 times x to the 4, so 2 to the 4 is 16, minus 12 is going to be 4. 4 to the negative 1/2 is another 1/2. So that gives me 8 as the derivative, or as the slope of the tangent line. And then I just plug in the point into the original function, and that will give me 4, or sorry, that'll give me 2. So another point of 2, 2. 16 minus 4 is 4, or 16 minus 12 is 4, square root of 4 is 2. So then we just get the equation of the tangent line is y minus 2 is equal to 8 times x minus 2. So we get y is equal to 8x minus 16 plus 2 is equal to 8x, minus 14. Does that make sense to everybody?
Yeah.
Cool. Find the values of x where the tangent line is horizontal for f of x is equal to this guy. So asking the tangent, or saying the tangent line is horizontal, is basically just the same thing as saying that the derivative is equal to 0. So I want to find the derivative of this guy and set that equal to 0. So that's going to be, the whole thing here is going to be, this is, I'm just going to re-represent this as to the 1/2 here. So then I do the derivative of the inside, so that's 3x squared minus 12x plus 9 is the derivative of the inside. And then the outside becomes, so times 1/2 times the original thing, so x to the 3 minus 6x squared plus 9x plus 1 all to the negative 1/2 now. So this guy right here, that is to the negative 1/2. So that's basically the bottom of a fraction. This whole thing is never going to be equal to 0, because if the inside, for the whole thing to be equal to 0, the inside of the square root would have to be infinite, and that's not going to ever happen. So instead, I just have to worry about when this guy is equal to 0. So first thing I'm going to do is pull out a 3 from that whole thing. So this is 3 times x squared minus 4x plus 3. So that factors into x minus 1 and x minus 3. And that happens that x is equal to 1 and x is equal to 3. Does that make sense to people?
Yeah, so can you explain again why the second half would never equal to 0?
So the second half, the inside can equal to 0. So the second half we can write as just the fraction here, x cubed minus 6x squared plus 9x plus 1. This guy, a fraction can only equal 0 if the top is equal to 0, right? And 1 obviously is never going to be equal to 0. And then the bottom would also have to be infinite, which that's not ever going to achieve. So even if you got the bottom to be equal to 0, that would be an undefined point, not a point where the derivative is equal to 0. Does that make sense?
Yeah.
Cool. a certain truck depreciates according to a formula. V of t is equal to 62,000 or 62,500 or 62,500 divided by 1 plus 0.02 t or 0.2 t plus 0.1 t squared, where t is the value of the truck in dollars and t is the time measured in years, and t equals 0 represents the time of purchase in years. Find the rate at which the truck value is changing after 3 years and interpret the function, or interpret the answer. So the rate at after 3 years, what am I going to do here?
You find the derivative by using quotient rule.
Yeah, we can use quotient rule here. So what is the derivative? So we're going to do what, the bottom times the derivative of the top. So that's 1 plus blah, 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 t squared, 0.1 t squared, times 0. The derivative of the top is 0. And that's why I didn't really worry about writing out the inside. This guy goes to 0. Minus top times derivative of bottom all over bottom squared. So 1 plus 0.2 t plus 0.1 t squared all squared. So what's the derivative of the bottom here? This guy becomes 0.2. This guy becomes 0.2 t. So the whole thing then becomes equal to is it worth simplifying this? So you can just divide through this whole thing by 5, and then you would get 12,500 times 1 plus t all over 1 plus 0.2 t plus 0.1 t squared all squared. And then I just plug in 3 into this value, and I should get, oh, there should be a negative here, and I should get negative 8,000 when I do that. So that I would just suggest you plug into your calculator, and you should see that's what comes out. Sorry, negative 8,000. And that basically means that the value of your truck after 3 years is depreciating at a rate of $8,000 per year. So that's dollars per year. Does that make sense to people?
Yeah, I just had a quick question, like in regards to the test. For when we do the derivatives of our equations, do we have to simplify at all?
I think that you are specifically told not to simplify for most of the problems, which it makes it like it eliminates places where you can make mistakes, and then it also it makes it easier for us to grade. So it would probably be better off for you to leave it in this form. Like just get rid of the 0 because the 0 is useless, and then just leave it like that as opposed to simplifying like I did there. But I think in terms of like actually demonstrating what's going on, it's probably a little bit easier.
Is the exam through my math lab like the tests?
So my math lab is going to provide the bulk of it, and then there's actually going to be 4 questions that would be like that you have to submit a PDF document for in the recitation section on Blackboard, and that you'll have from 12:01 on Friday to 11:59 on Friday for. So you'll have 23 hours and 58 minutes to write that up.
Okay.
Cool. I think it's only 4 problems, I'm pretty sure. But yeah, let's actually just switch over to the exam 1 review then.
And one last question about the exam. So it's from 11.1 to 12.2?
That sounds right.
Okay.
Yeah, I know that it covers the quotient rule. So it at least, and I think it starts at the first thing we covered, and then it goes to at least the quotient rule.
Okay, so we don't have to like go through like derivative logs or anything.
So oops. So I guess this will. I suppose you do have to know the derivative log because it is on the review sheet that Jean posted on the website.
Okay.
And for anyone who doesn't know, Jean is one of the 2 professors. I don't know if it's people who are just in Jean's class or if there's also people in Adam's class here. Their coordinating course. Any other general questions before I dive into this?
So do we just write the problems down and do them in our notebook and then kind of take a picture, or do we have to kind of enter it in, like type in the work?
If you want to type in the work, you're welcome to, but yeah, as long as you have somewhat legible handwriting and everything's in like a fairly linear order, it's fine to just submit pictures. My only request is please submit a single document with all of the questions in order. It just makes it a lot easier to grade.
Okay.
Thank you. So use the definition of the derivative to find the derivative for each of these functions. So a right here is going to be, so we have to jump back to the limit definition of the derivative here. So if I were to plug in this f of x plus h, this becomes negative 15 times x plus h squared minus 6 times x plus h minus 12, and then that's minus negative 15 squared x minus 12 all over h. So this guy becomes negative 15x squared plus 30xh plus h, or minus 15h squared. You should also be minus there. So minus, minus, minus. And then minus 6x minus 6h minus 12 plus 15x squared plus 6x plus 12. This cancels with this cancels with this, and this cancels with this. Everything I'm left with, that's all over h. Everything I'm left with should still have an h. So minus 30xh minus 15h squared minus 6h all over h. This cancels, this cancels, this cancels. And I am left with negative 30x minus 6 plus, or minus 15h. But this whole time, I should have been writing limit as h goes to 0, and I wasn't for the sake of time to cover as many of these questions as possible. So that 15h goes to 0. I'm just left with negative 30x minus 6. And if you were to do the power rule, that's exactly what you would find. This guy becomes negative 30x, this guy becomes just negative 6, and this guy disappears. Does that make sense to people? Do people follow that?
Yeah.
Cool. This one's a little bit harder. This is the first one that we've seen together. I don't know if it's if you guys have covered it in class otherwise, but this is the first one that is not a polynomial for the limit definition. So this is 9 over x plus h, and then that's minus 9 over x all over h. So the easiest thing to do here is multiply by x over x and x plus h over x plus h to get them to have the same denominator. And again, this is the limit as h goes to 0.
So for something like that, if we have the definition for one of your questions, writing it out, if it says use the definition of the derivative, we have to use the difference formula. We couldn't use like the quotient formula for that.
Yeah, if it says use the definition, then you have to use the limit definition.
Okay.
All of the other things are just rules that are derived from the limit definition. So yeah, it's annoying, but that's what you have to do. So that becomes 9x minus, now they have the same bottom, so 9x minus 9x minus 9h, just to distribute this guy over x plus h times x, and then also divide by h. Does that make sense? Sometimes people are uncomfortable with that. You can also think of this as the whole time I was multiplying this by 1 over h, and then I think that people find it a little bit more natural, but they're the same thing. So the 9x's cancel, and I'm left, and then negative 9h over h times x plus h times x. So the h's cancel, and I'm left with negative 9 over x squared plus x h, and then this is the limit as h goes to 0, and this guy disappears. So I get negative 9 over x squared. Does that make sense to people?
Yeah.
Cool. So consider the function f of x is equal to negative 1 over x minus 3. Find the average rate of change of f from x is equal to 4 to x is equal to 8. So this is just saying that I have to find the slope between these 2 points. To do that, I need to do plug in what their values are. So this is going to be, so m is equal to y1 or y2 minus y1 over x2 minus x1. So if I plug in 8 into this equation, I get negative 1/5. So it's going to be equal to negative 1/5 and 8 there. And then if I plug in 4, I get negative 1. So minus negative 1 and minus 4. So this guy right here is equal to 4 over 5 divided by 4. So that's equal to 1/5, right? So that is going to be the average rate of change over that distance. Does that make sense to people?
Yes.
Cool. And so now the equation of a secant line is going to have the same slope. So the secant line is similar to the tangent, but it goes through 2 points. And we just found what the slope of it is. So we now pick one of our 2 points. Somebody tell me which one you want me to pick.
Just do the first one, f comma f of 4.
Yeah, that is definitely the easier one. So thank you for picking that one. So y minus negative 1 is equal to 1/5 times x minus 4. So then I get y is equal to 1/5 x minus, then we get 4/5 minus 1. So that's 1/5 x minus 9/5. Does that make sense to people?
Yeah.
Cool. So consider the function f of x is equal to -1/x. Find the instantaneous rate of change of f at x equals 4. So the instantaneous rate of change, that just means that we're dealing with the derivative. So we want to find, and then I'm just going to rewrite f of x as equal to -x to the -1. And then so we get f prime of x is equal to, negative times negative is positive. So I get, or then it just becomes x to the -2. So then if I do the instantaneous rate of change at x equals 4, then f prime of 4 is going to be equal to 1/16. Cool. And find the equation of the line that is tangent to the graph at f equals 4, or f equals the line that is tangent to the graph of f at x equals 4. So then I'm just going to plug in f of 4 is equal to -1/4, and then I have x, so 4, so y is equal to y minus -1/4 is equal to 1/16 times x minus 4. So that is y is equal to 1/16 x minus 1/4, and then minus another 1/4. So I get y is equal to 1/16 x minus 1/2. Does that make sense to people?
Yeah.
Cool. So consider the functions defined below. Find each limit. So g of x is equal to that, yeah. So g of x as x approaches 100. So as x approaches 100, the top would approach 0 and the bottom would also approach 0. But I can basically change g of x to be, so that's basically equal to this guy, x minus 10 times the square root of x plus 10. This guy cancels with this guy at almost every point. So if I were plug in 100 now, I would get that it's equal to 1/20. Does that make sense to people?
Yeah.
Cool. So the next one, the limit is a polynomial. Polynomials are continuous everywhere. Therefore, if you just plug in the value, you'll get what the limit is. So if I just plug in for p of x, here I'd get -4 times -8 plus 5 times 4, right? -2 squared is +4, plus 18 times -2. And all of that comes together to be 16. Right? So this is 20, this is, why is that 16? Oh, because this is +16. And then this is -36. Oh, sorry, this is 32, not 16. Okay, so yeah, that's why it comes together to get 16. Cool. So we're going to do something similar to the previous problems here for R. So what is the top guy equal to? How can I factor the top? So the bottom is a difference of 2 squares, right?
X
What
plus
about
x minus 2.
x minus 2, x plus 8? Exactly. So almost everywhere these guys just cancel. It's going to be undefined at the point x equals -8, which is the one that this is asking about. But other than that, but this is also going to, this function right here is going to define the limit as x approaches -8. So I can just plug in -8 and I get equals to -10 over -16. So this is going to be equal to 5 over 8, right? That makes sense to people?
Yes.
Cool. So then the top, then this next one here, I can just plug in, it's defined on top and bottom, so it's continuous at the point 2. And this guy is also going to define the limit everywhere. So I can just plug in the value to that. And guess what? I get 0 on the top and something that's not equal to 0 on the bottom. So I get 0. And then here, I would get a positive number on the top and then 0 on the bottom. So this is actually going to be, this is going to be the limit does not exist. So the limit does not exist because when I approach 8 from above, I get positive infinity, but when I approach 8 from below, I get negative infinity. Does that make sense to people?
Yeah.
It looks something kind of like this. The graph. Cool. Was somebody going to ask a question? Okay.
No, I was just saying I understand it.
Okay, cool, good. So let's see how many more I can get through in 8 minutes. So the worldwide box office receipts for a long-running blockbuster movie are approximated by the function m of t is equal to 120t squared divided by t squared plus 4, where m of t is measured in millions of dollars and t is the number of months since the movie's release. With what will the movie gross in the long run when t is very large? So how much when t is very large, like what is, this is basically asking what is the limit of m of t, limit as t approaches infinity of m of t. Do you guys remember the rule? So we look at these guys, we compare their lead power, and the lead powers are the same, right? So that means that it's just the coefficients, the ratio of the lead coefficients that we care about. So that's just going to be 120. So that is the number of millions that it will approach. Does that make sense to people?
Yeah.
Cool. This again is a very similar thing. It's basically the same set of rules that we're playing with here. So the top right here, the bottom for A, the bottom has a bigger power than the top. So what does that mean as x approaches infinity? What does that mean? Somebody shouted at me. Come on, guys, we have a rule for this.
Is it just 0?
Exactly, it's just 0. So that just means that the bottom grows much, much faster than the top does, so it approaches 0. And then the opposite, if the top has a bigger lead power it approaches either positive or negative infinity. What's it going to do here?
Positive infinity?
Exactly. What about here?
Negative infinity.
Yeah, cool. So positive infinity, because both the top and the bottom are always going to be positive. But here, or not always, but as you go off to infinity, they're always going to be positive eventually. Here, the top is going to be positive because we have an even power right here, and then it's got a positive coefficient. But the bottom is going to be negative because it's got a positive coefficient times an odd power. So as we go off to negative infinity, an odd power is going to be negative. Negative times positive is negative. So this whole thing ends up being negative infinity. Cool, makes sense?
Yeah, so to determine which sign is for infinity is to determine if the exponent and the coefficient is positive or negative, or even or odd.
Yeah, so if the coefficients are even or odd, as we go to negative infinity. So if we're in the positive direction, it doesn't matter. They're always going to be positive. But if we're going the negative direction, an odd lead coefficient means that your term is going to be negative, right? So something like x cubed as x goes to limit as x goes to negative infinity is going to be equal to negative infinity, even though it's got a positive coefficient.
Okay.
So you just have to keep track of how many positive and negatives there are to see how they cancel each other out. And in this case, we have one more, or we have an odd number of negatives. We actually only have one negative of the four things we have to look at: the coefficient of the top, coefficient of the bottom, and then the power of the top, power of the bottom.
So what happens if the bottom the highest coefficient or the highest power would have a 15? So if there's two positives on the top and two negatives on the bottom, or two odds on the bottom.
So you mean like if we had negative 15 x to the 5?
If we have an odd number for the coefficient and the power on the bottom and an even coefficient and power on the top. So if it was even rather than it exceeds a certain.
So for the coefficient, I don't care if it's odd or even. So like if this was 3x to the 6 instead, that wouldn't affect it. For the coefficient, I care if it's positive or negative.
Okay.
The reason I care about the exponent if it's positive or if it's odd or even is because if it's odd or even tells me as I go off to negative infinity, is this going to be odd, or is this going to be positive or negative? Because
okay. Yeah.
Well, that makes sense.
Yeah.
Cool.
So what's the circumstance in which you divide everything by the highest power in the denominator?
That was just like a trying to show you guys the more rigorous reasoning behind why something goes off to positive or negative infinity, or zero. But the basic rule that it, just like how we worked with the limit definition, or like just the basic rules of thumb, it's going to be easier to think of, hey, this is bigger power, this is smaller power, therefore this is going off to the top has a bigger power than the bottom, therefore it's going off to positive or negative infinity, and then I just have to check. But if you want to do this like much more rigorously, you would divide through everything by x to the 5th, and then you would get that the bottom, so you get the top is equal to 2x plus 19 x to the negative 4 minus x to the negative 5 over 16 minus 18 x to the negative 1 and plus 10x to the negative 5. And then these guys would go to 0, and I would just be left with something that clearly goes off to infinity, right?
Okay. Yeah.
So basically that's like the more rigorous way of thinking about it, but the rules work perfectly fine for the most part. We're also out of time, so I won't have time to go over the 4 remaining questions. But I might end up reviewing them in my other sections. So if I post those to YouTube, I'll just send out an email saying, hey, questions 7 through 11 on the review are in whatever video. Cool.
Yeah, when are your office hours again?
So my MRC hours are, I had them earlier today. Let me just check my calendar to make sure I don't give you wrong information. So it's Monday from 10 to 11, and then Tuesday from 4 to 6. Sorry, both of those are Wednesday. Wednesday, 10 to 11, and 4 to 6.
Okay, thank you.
And also, you can go anytime, and somebody will be able to help you. Anytime that the MRC is open, but those are my hours.
Okay, thank you.
Cool. Have a good one, guys.
Thanks.
Thank you.
Thank you.